The inverted L is a staple for getting onto the low bands, particularly 160 meter and 80 meter, which may be necessary as you are heading for the minimum of solar cycle 25. When you don't have the sheer vertical real estate required for a full-sized vertical antenna. It is essentially a quarter wave Marconi antenna where the top portion is bent horizontally to fit into a typical residential footprint. Because the feed point is at the bottom, the highest current portion of the antenna is in the vertical section. This defines its radiation characteristics. The vertical section, this part does the heavy lifting. It radiates a vertically polarized low angle signal that is excellent for DX communication. The goal is to make this vertical run as long and clear of obstacles as possible. The horizontal section. This section acts primarily as a capacitive top loading. It brings the antenna to resonance without requiring a massive tower. While it does radiate some horizontally polarized high angle signals, which can be useful for NVIS or local contacts. Its main job is to complete the electrical length of the antenna. The total length of the wire, vertical run plus horizontal run, should be approximately quarter lambda for your target frequency. For 160 meter, roughly 130 to 135 feet of wire. For 80 meter, roughly 65 to 70 feet of wire. The slightly long trick. When building an inverted L, a common practice is to cut the wire slightly longer than quarter lambda. This causes the antenna to exhibit an inductive reactance at the feed point. You can then insert a simple variable series capacitor at the base to tune out the reactance and dial it for a perfect match, making it much easier to tune than trimming wire inches at a time. Because the inverted L is an unbalanced quarter lambda antenna, it is only half of the radiating system. The other half is the ground. The efficiency of an inverted L is entirely dependent on its counterpoise. Ground mounted. If you feed it at ground level, you need an extensive radial field to minimize ground losses. While broadcast stations use 120 radials, laying down 16 to 32 radials of varying lengths will give you excellent amateur performance. Elevated radials. If you can elevate the feed point even a few feet off the ground, you can use 2 to 4 resonant elevated radials. This drastically reduces ground losses and requires far less wire than a buried radial field. A perfect quarter lambda vertical over a perfect ground has a feed point impedance of roughly 36 ohms. Because the inverted L bends the top section over, the radiation resistance drops further, often down to 15 to 25 ohms, depending on how high the vertical section goes before the bend. Connecting a 50 ohm coax directly to this will result in an acceptable but not perfect SWR, usually around 2:1 or 3:1. To get a 1:1 match, homebrewers typically use a base matching unit, an union like 2:1 or 1.5:1 ratio to step the impedance up, or a simple L network, a shunt coil and a series capacitor enclosed in a weatherproof box at the feed point.